Okay, assalamu alaikum dear students. So last class we learned how to do HCF of like one terms, like the expression like which did not have a plus or minus in between. So today we are going to learn how to find HCF of different algebraic expressions. Let's say we have a problem. I have three expressions. It's x square minus 9, okay, then x square plus 7x plus 12, then 3x plus 9. So I need to find out the HCF. So first of all, we need to factorize all three expressions. How can we factorize? X square minus 9 can be written as, you know that this is a form, can be written as x square minus 3 square. So a square minus b square equals to what? A plus b into a minus b. So x plus 3 into x minus 3, right? So similarly, x square plus 7x plus 12, so this also can be middle term factor, right? We can do it. X square plus 4x plus 3x plus 12. So we can break it down, x into x plus 4 plus 3 into x plus 3 into x plus 4. So finally x in x plus 4 into x plus 3. Now the last part, 3x plus 9. So how to factorize this? We just take 3 common, 3 into x plus 3. So what will be the HCF? You see x plus 3, x plus 3, x plus 3 is common in all three expressions. So my HCF will be only x plus 3. That is, okay, so this is my answer. So I'm going to show a few more examples on HCF. I think this is quite easy. You can understand, right, how to determine HCF. Let's say I have two more expressions. I will find out the HCF. Okay, so let's say x cube plus 6x square plus 8x, then x4 minus 5x square, and this side no, not this expression. It's actually x cube minus 3x square minus 10x. So I need to find out the HCF of these two expressions. So how can we factorize this? Let's say for this you can write x cube plus 6x square plus 8x. So we just draw a line. So x cube plus 6x square plus 8x. First of all, we take x common, okay, because all three expressions has x. Then we can write x square plus 6x plus 8. Now we put a second bracket. X square plus 6x plus 8, we know we can break it down into 4x plus 2x. 4 into 2 is 8, right? So x square plus 4x plus 2x plus 8. Actually this did not require a second bracket, but the next line will require a second bracket. X, we take x common from these two, x plus 4 plus 2 into x plus 4. So finally what do we have? X into x plus 4 is common both sides, and x plus 2. X into x plus 4 into x plus 2. Now we move on to this x cube minus 3x square minus 10x. If we take x common, we can write x square minus 3x minus 10. Then again x. For 10, you know, for there is one the coefficient over is 1. 1 into 10 is 10. But how to get 3? You see, there is a, with the factors which will get you 3 is 5 and 2. 5 2s are 10. So we can write x square. If there is 2 minus, 1 minus, 1 minus, both are minus, we need to add plus in between. X square minus 5x plus 2x minus 10. So minus 5x plus 2x equals to minus 3x. So x, then we take x common from here, x minus 5, then plus 2 common, 2 common from both sides, 10 is also divisible by 2, then x minus 5. Finally what do we have? X into x minus 5 and x plus 2. So you see, what is LCM? X is also common, x plus 2 is also common. So my HCF, required HCF is x into x plus 2. So I'm sure you understood what is HCF. HCF means we just need to take the common parts from both of them. LCM is we need to take first the common parts. Okay, now I'm talking about LCM. Okay, HCF I'm sure you understood. We just need to take the common parts. X into x plus 2, x into x plus 2, that's the common parts. So this is the HCF. Now what about LCM? LCM is actually the same thing. We just first of all we take the common part, but we also take the uncommon part as well. So let's say for these two expressions, if I need to find out the LCM would be the common parts. First I write it down, x into x plus 2, and then the uncommon parts, that is x plus 4 and x minus 5. So this, the LCM would be for these two expressions, the LCM would be the common parts and then the multiple of the uncommon parts, x plus 4 and x minus 5. Okay, so that is the main difference between HCF and LCM. So we will try and solve more, like we will try and find out LCM of different expressions. I'm sure you will. You see, if you know exercise 5.3 well, 5.4 is very easy for you. It's actually, we just need to factorize, then we just need to take the common parts for HCF and the uncommon parts and the common parts for LCM. That's it. So the main thing is you need to be able to solve exercise 5.3 properly. Then you can solve these things in a very swift way. Okay, so let's say I have a problem and 3x square y cube, 9x cube y square and 12x square y square. I need to find out LCM. 3x square y cube, 9x cube y square and 12x square y square. So 3x square y cube can be written as 3 into x into x into y into y into y. 9x cube y square can be written as 3 into 3 into x into x into x into y into y. And finally 12x square y square can be written as 2 into 3 into 3. 2 3 is 6, sorry, 2 into 3 into 2. 2 into 3 into 2. 2 2s are 4, 4 3s are 12. Into x into x into y into y. So this I have written. Now what will be the LCM? First I'll take the common parts. So 3 is common, 3 is common, 3 is common. So 1 3 is common. Then the uncommon parts. For the numbers, I'm talking about the numbers. So 1 3 is uncommon, we write 1 3, and these 2's are also uncommon, so we write this. Okay, now let us consider x. 2x 2x 2x. Okay, so 2x's are common, so we can write x into x. And now the uncommon part. So the common part's gone, we have the uncommon part, that is x into how many y's common? 2 y's 2 y's 2 y's, y into y, and then the uncommon part. This is the uncommon part, right? so into y. So what will be my LCM? 3 into 3 is 9, 9 2s are 18, 18 2s are 36, x cube, and finally y cube. So if you notice here, for LCM the highest power of x is what? X cube, and for y the highest power is y cube. So in LCM we have to take, if we have expressions, okay, usually for LCM we need to take the variables with the highest power. So answer, if you see the answer you can understand, x cube, y cube. So the highest power of x is x cube, highest power of y is y cube. This will automatically come into LCM, and then you just need to find out the LCM of 3, 9 and 12. So we already know how to find out 3, 9 and 12, right? LCM we can do by prime factorization. 3 1s are 3, 3 3s are 9, 3 4s are 12, then with 2 1 3 2. So 3 into 2, 3 into 2 6, 6 into 3 18, 18 into 2 36, so 36. For alphabets or for variables we just need to take the variables with the highest power, okay, y cube, x cube, y cube, x cube. So you don't need to even break this down up, you just take out the variables with the highest power, put it down, and just find out the LCM of the numbers 3, 9 and 12. Okay, very simple. Now we will move on to LCM of more than, like, the LCM of expression which has more than one terms. Here these were the LCM of monomials. If you remember about monomials means only one term. Polynomials means the expressions which have more than one term. Okay, so this is actually an LCM of monomials. Like this is also a monomial, this is a monomial, this is a monomial. Now let's say we need to find out the LCM of polynomials. So let's say I have a question: x square plus 10x plus 21 x4 minus 49x square. So I need to find out the LCM of these two expressions. So first of all, this you can see this is this has three terms, so we can break this down in by using middle term factor. So x square, we know 21, the factors of 21 is 7 and 3, so we can write 7x plus 3x plus 21, so equals to, we take x common from here, x into x plus 7 plus 3 common, x plus 7. So finally what do we have? X plus 7 into x plus 3. So this is for the first expression. For this expression, first of all we see we can take x square common, so we can write x square minus 49. Then we can write x square, we can just put a second bracket and we can convert this into x whole square minus 7 whole square. We can write x square minus 49 in this way: x whole square minus 7 whole square. So we know that a square minus b square equal to a plus b into a minus b. So x square x plus 7 into x minus 7. So what are the common terms over here? X plus 7 and x plus 7. So my LCM will first, for LCM we will first write down the common term x plus 7. Now we start with the uncommon part, x square. So we just write x square over here, then x plus 3, then x minus 7. Okay, so LCM is all about writing the common and uncommon expressions. Okay, so this is my LCM. Alright, so I hope this is quite clear how to find out the LCM of different, like, monomials. This is how to find out the LCM of monomials, and this is how to find out the LCM of polynomials. so I'm sure this is quite easy, and if you have any problem you can still ask. But this chapter is all about this. You need to find out the LCM of different expressions. That's it. Very easy. So I won't explain furthermore because all the problems are quite similar. You just need to factorize. If you can factorize different algebraic expressions, then you just need to find out the common parts. Like for LCM, you first find out the common parts, then write down the other uncommon parts. That's it for LCM. HCF, you just need to find out the common parts. That's it. Okay. If you have any problem understanding this, you can ask. Remember that the factorization which you have done in exercise 5.3, not only you will require this in exercise 5.4, you will require it in exercise 6.1, 6.2, exercise 7.1, 7.2, 7.3 as well. Okay, so remember that you practice more and more of factorization. Okay, different types of factorization you need to practice. Okay, alright, so thank you very much for today's, and have a nice day then. Okay, Assalamu alaikum.